Well friends, a big hello to everyone. Today we'll have the jpt60m7 f1.63 lens. I'm Igor, Gravity Engraving Channel, the channel about laser machines and markers. Today we're going to talk about interference color. Today's topic is about the long-standing problem of selecting the right parameters and characteristics to get these beautiful shimmering colors. Let's cover our lens so you have no doubt that everything looks beautiful and wonderful even with the lens covered. So there's no reflection from the lens or anything else like that. I'll zoom in and show you everything now. Today we'll briefly go over how this is possible on the jpt60m7, and that a lot of time was spent here, about 8 hours today. Not all metals are equally suitable, and not all surfaces work well. So in this case, we got absolutely nothing, even though it's also stainless steel. Maybe it needed polishing, maybe. If we take that same polished surface, then here, well, something worked, but it's just not right. It's not the same vibe, not the same effect, as they say. Same situation with the 430, it works in some places and not in others. We'll set this piece aside, but we have other pieces where it more or less worked out. But here we really... Yes, it worked here. Well, in theory, I'll show it later under 3x magnification. How it all looks right here on this piece of metal. Not everything is perfectly good, of course. So there are, again, certain types of metals where it all works. A whole bunch of tests were done today. Here, for example, yes, the test went great. The bottom row failed the test because only the top layer or the top row turned out well. Let's zoom into 3x. It'll probably be better. While I'm showing it, I'll explain. It's directly affected by the frequency range. Is it possible to do this on Raycus? Or Max Photonics Q-Series or Q-Switch models? I'll tell you right now, no, don't even bother. Please, with your machines, it won't work on them. There are certain conditions under which this can be done. We're currently working on a jpt60m7 with the letter E, not E2. I repeat once more, not E2. So it's the regular E version, the classic one as it's always been, as it always works. Moving on. It's essential to select the frequency range, and it's essential to select the fill density parameters. This will, of course, affect the engraving quality and stability depending on the metal types. Many tests were also done here, and not all of them were successful. The ones you see here were tests, already completed and refined afterwards. Here we also tested possible options and achieved a certain stability at a specific density, which actually made us very happy, and we started working further. Here we got absolutely nothing, meaning we punched a whole bunch of hexagons and the result was absolutely nothing. Something is working here, but I didn't like the result, so I basically excluded it entirely. These options, this engraving was already the final result during the metal tests. So I think we've looked at this. There are also various beautiful options here, depending on the fill density and the selection of parameters. These tests were done at the very end on scrap pieces of metal, so we were running low on clean metal, and we just used whatever we could find. And accordingly, I tested the final version many times for repeatability stability, so the bottom ones repeat stably, specific frequency ranges, fill density, the Q pulse itself, and much, much more. That's why I decided that we should move exactly in this direction. After conducting many more tests, I have some separate ones here, and I got a stable result. After that, naturally, to check the stability of these engravings, I had to run the tests once again, to make sure once more that everything's working correctly. I made a slightly stretched out version of the engravings after running some specific tests. I also made the same engraving on metal as I did before with the picosecond laser. So it all worked out, it's beautiful, but the only thing is, unlike the picosecond laser, it's very pronounced in normal mode. Meaning in normal mode, if we look at it, the engraving is very clearly visible. On the picosecond laser, of course, it wouldn't be visible. Anyway, after testing all possible options, I did another test like this, with slightly different parameters. It also turned out stable, cool, beautiful, everything's great. Yes, again, at a certain angle, it all shimmers very beautifully. Not as cool, of course, as on the picosecond laser. But I like that everything here is also as stable as possible. How much time was spent? We started working today around 11 in the morning, and it's now past 7 in the evening, so according to our math, that's about 9 hours. Taking into account a short lunch break, we ended up with about 8 hours of time spent on these tests and experiments. You can see that everything works out great, almost like on the picosecond one. Not as bright or saturated, of course, but overall good too. A plus of working on the MOPA series. We can rotate our workpiece and it will be visible from almost any angle. Getting such a bright, saturated interference color. On the picosecond, because of the beam polarization, we won't get that result from different angles, but it's very bright there. A saturated, stable color comes from exactly one direction. So, as always guys, give this video a big thumbs up. Regarding the info on how it was done, how it was achieved, the modes and parameters, all of that will be done separately and recorded as additional educational material. I've already done it for ESCAD 3.0 and I'll upload it now. Specifically, into a separate tutorial for ESCAD 3.0. For ESCAD 2.0, I'll either record it under ESCAD 3.0 and add it there. But there's no other way because right now, my Mac 67 is set up specifically for ESCAD 3.0 for the dynamic galvanic scanner. Setting up something else right now, unfortunately, alas, won't be possible for me. And so, accordingly, based on the work algorithms, I think each of you using ESCAD 2.0 will be able to replicate and do the same on your own machines. Here we've just done it on the machine. jpt60m7 f163 lens with a 100 by 100 work field in ESCAD 3.0 and ESCAD 2.0. I'll repeat once more, the same can be done all the same. Right now I don't have the opportunity to do it. Once I have the machine, I'll definitely do it and add it to ESCAD 3.0. That's all guys, Igor here, Gravity Engraving Channel, a channel about laser. Just once more, machines and markers. All of this takes a colossal amount of time. Naturally, it has to pay off somehow, so I do this for our clients, our subscribers, for those who purchase training materials, for those who actually buy machines from us. I can share this information with them too. Such information. Alright, peace and prosperity to everyone and bye-bye.